Dear student, welcome to all of you in my online Maths class. In this video class, we will discuss the next topic of the binomial theorem, and that is the general and middle term. General and middle term of the binomial theorem. And I will also solve some question related to exercise 9.2 and give the PDF of that exercise. So let us see the general expansion of binomial theorem. Here a plus b raised to the power n can be expanded as nc0 a raised to the power n plus nc1 a raised to the power n minus 1 b plus nc2 a raised to the power n minus 2 b square, like that, and plus here ncr a raised to the power n minus r b raised to the power r. Okay, I want to write its general term. General term. So general term will be t r plus 1. Here general term, since there are n plus 1 element, the general term will write like this way: t r plus 1 n c r a raised to the power n minus r b raised to the power r. And here its last term will be like this way: n c n a raised to the power n minus n will be 0 and b raised to the power n. The general term will be t means r plus 1 term is equal to ncr a raised to the power n minus r b raised to the power r. This is the general term. Okay, just like if I want to write here x plus y raised to the power 10. Okay, and I want to write seventh term here, t7. So we can write t7 like t6 plus 1, means at the place of r now 6, and then we can write 10 c6 a raised to the power 10 minus 6 b raised to the power 6, means 7th term will be like this. It means 10, here it is x plus y, then here we write x and here y. Okay, then it will be 10 cr x raised to the power 4 and y raised to the power 6. Here the coefficient of this term is 10c at the place of r 6, 10c 6. So in this way we can write general term using this concept: t r plus 1 is equal to ncr a raised to the power n minus r b raised to the power r. But what happened if the extension is general term in the different case of binomials? Just right there, if we have general term in the case of a minus b raised to the power, general term in the case of a minus b raised to the power n. Here in the expansion of a minus b raised to the power n, general term is equal to tr plus 1, and here it will be ncr. Okay, a raised to the power n minus r, and then minus b raised to the power r. We can write here minus 1 raised to the power r ncr a raised to the power n minus r b raised to the power r. This is the general term in this case. Okay, similarly in the expansion of general term in the expansion of here a plus x raised to the power n, general term will be equal to ncr here a raised to the power, what is the concept? 1 raised to the power n minus r and x raised to the power r. But whatever power will be 1 raised to the power n minus r, it will be always 1 and its value will be NCR x raised to the power r. So we can write here NCR x raised to the power r. So general term in the expression of 1 plus x raised to the power n is NCR x raised to the power r. Getting? Similarly, in the expansion of 1 minus x raised to the power n, general term are here tr plus 1 is equal to minus 1 raised to the power r and NCR x raised to the power r. This will be the general term in the expansion of this image. Okay. Now, one more thing I want to tell, that is the coefficient will be in the case of here if we write to 1 plus x raised to the power n, its general term if I want to write, then it will be NCR x to the power r. And in the case of minus here, it will be minus x to the power n. Okay, its coefficient will be NCR. In the case of plus, the coefficient will be this, and in the case of minus, the coefficient will be this, like this here. Okay, the coefficient is NCR. Now, here in terms from the end of the expansion a plus b raised to the power n is rth term from the beginning in the expansion of this function. Rth term from the end of the expansion. Here in the expansion of a plus b raised to the power n term from the n r, we can write rth term from the n, we can write it rth term from the n is equal to rth term from the n in the expansion of a plus b raised to the power n is equal to rth term from the beginning in the expansion of b plus a. Okay, be careful. Rth term from the end of the expansion of a plus b raised to the power n is equal to rth term from the beginning, here b plus a, here a plus b from the end, then from the beginning will be b plus a raised to the power n. Getting? Rth term from the end in the expansion of a plus b raised to the power n is equal to rth term from the beginning in the expansion of b plus a raised to the power n. That is way we can also find. Now we will discuss about the middle term. Middle term. Yeah, now we will discuss middle term. Middle term are terms. Okay. Now we will discuss about the middle term or the terms. Dear student, in the beginning of this topic, it was explained that total number of terms in binomial expression is n plus 1. Means if the power is n, means a plus b raised to the power n, then its expansion, then the number of terms will be n plus 1. If the a plus b raised to the power 5, then number of terms will be 6, means 5 plus 1. If a plus b raised to the power 20, then the number of term will be 20 plus 1 means 21. So if the power is n, then total number of term will be 1 more than its power. So similarly here, the middle term in the expression of a plus b raised to the power n, then the number of term is equal to n plus 1. Here the number of term will be n plus 1. Now if n is odd, if n is even, then what happens? And similarly we will discuss if the value of n is odd. Okay, if the value of n is even, in that case the total number of term will be odd. Try to understand. If n is even, just like if n is 6, then number of term will be 7, because here we find that a plus b raised to the power n. Then in this expansion the total number of term will be n plus 1. Okay, but here if the value of n is 6 means even, then total number of term will be odd, and in that case middle term is equal to t n by 2 plus 1. T n by 2 plus 1 means if 6, then 6 plus 1, 6 by 2 plus 1 means fourth term will be the middle term. Get it? Just like here, if we have x minus 1 raised to the power of 6, okay, then its middle term is what? Its middle term will be t 6 by 2 plus 1 term. This term. It means it will be t 3 plus 1 term. Okay. Now you can find this t3 plus 1 like 6 here minus, then we can write minus 1 raised to the power r. Here this is follow this way, tr plus 1 is equal to minus 1 raised to the power r ncr a raised to the power n minus r b raised to the power. We use this concept here in this case. Then it will be minus 1 raised to the power 3. Why 3? Because it is r. The middle term is t4. According to this, the middle term will be fourth term. We can write t4 term. Fourth term. Okay. But t4 can be written as t3 plus 1. And according to this concept, minus 1 raised to the power r is 3. 6c3. Okay. Again, x raised to the power 6 minus 3 and y raised to the power 3. Get it? Then its middle term will be here minus 1 raised to the power 3. It will be minus 6c3 x raised to the power 3 y raised to the power 3. Okay. Then coefficient of this term, fourth term, the coefficient of the fourth term are the coefficient of the middle term in the extension of x minus y raised to the power 6 will be 6 minus 6c3. And now we can get 6c3 is what? Factorial 6 upon factorial 3 for this and factorial 6 minus 3. Getting? Now we can write here 6, 5, 4 into factorial 3. Here factorial 3 and here 6 minus 3 again factorial 3. This can be written as 3 into 2 into 1. Factorial 3 cancel. 3 2 just 6, here 6, 5 4 1. It means its value will be minus 1 x cube 1 cube. Okay? In the question is different type of question will be asked from here. Just like in the extension of x minus y raised to the power 5. X minus y raised to the power 6. What is the middle term of this value? Then it is t 6 by 2 plus 1 using this formula. If n is even, then middle term will be t n by 2 plus 1 term. Okay? In this case, we can find that the fourth term will be the middle term. And how we find the middle term? T4 can be written as T3 plus 1, and using this formula we can find if the coefficient are, then the coefficient will be minus 20, and if the term directly asks, then it will be minus 20 x cube by q. But what happens if n is odd? What happens if n is odd? Okay, if n is odd means we want to find the middle term when the power of the binomial means a plus b, the power of the binomial is odd. If n is odd, then the number of terms in the expansion is even. Okay, if n is even, the number of terms will be odd. But if n is odd, then the number of terms will be even. For example, if the value of n is 7, in that case the number of terms will be 7 plus 1, that is 8, which is even. If n is odd, means if n is 9, the number of terms will be 10, okay, which is also even number. So if n is odd, then the number of terms in the expansion is even, and so there are two middle terms. If n is even, in that case there will be two middle terms, that will be n plus 1 by 2f term. The first middle term will be this n plus 1 by 2f term, and the second middle term will be n plus 1 by 2 plus 1f term. Okay, here this is the first middle term and this is the second middle term. If n is odd, okay, if n is odd, then number of terms, total number of terms is what? It will be even. Okay, if n is odd, then total number of terms will be even, and if it will be even, then in that case that binomial expansion has two middle terms. And how we find the middle term? The first middle term will be n plus 1 by 2f term, and the second will be n plus 1 by 2 plus 1f term. Okay, for example, if we have x minus 9 raised to the power 9, okay, 9, then middle term is what? Middle terms are p 9 plus 1 by 2, so 9 and 1, 10 plus by 2 will be 5, p5 and p6 are the middle term. Okay, in the case of x minus 5 raised to the power 9, the middle term will be t5 and t6. Using the formula n plus 1 by 2f term and n plus 1 by 2 plus 1f term, the middle term will be t5 and t6. Now if you want to find the t5, then you can write here t4 plus 1, and using the concept, that is here minus 1, so we can write minus 1 raised to the power r. Here r is 4. Get it? R is 4. Then 9c, we want to find 4. So here, because this is in the form of r plus 1, so 9c4, x raised to the power 5 and y raised to the power 4. In this way, this will be the first middle term. Similarly, t6 we can write t5 plus 1, and then it will be minus 1 raised to the power 5, 9c5, x raised to the power 4, y raised to the power 5. In this way, we can get two middle term t5 and t6. Here some questions are given in the form of example. Find the seventh term in the expansion of minus space. Let us see one exercise question. Here, write the general term in the expansion of this x square minus y raised to the power 6, and the second question is x square minus xy raised to the power 12. Let us see one question. Here the first part, we have to write the general term x square minus y raised to the power 6. We want to write the general term. So general term, how we write? T General term, how we write? Which formula we should use here? By writing the general term, it was explained earlier. General term is equal to TR plus 1, TR plus 1, that is NCR, A raised to the power n minus r, b raised to the power r, in the extension of a plus b raised to the power n. This is the general term. Okay? Here we have to find the general term in the extension of this value. So how we should write it? Let us see. General term. General term is TR plus 1. The same concept we should use here since in the extension of a plus b raised to the power. So here therefore TR plus 1 part is I am writing out there for this. NCR means 6CR. Okay, but here minus, so we should take minus first. Minus 1 raised to the power r. Okay, 6CR x square raised to the power 6 minus r and y raised to the power r. Like this here, we can write this general term. Or simply we can write minus 1 raised to the power r, 6CR x raised to the power 2 6 are 12 minus 2r and y raised to the power r. In this way, we can find this general term in the case of this general term. The second question is find the third term. Similarly, the second and third part also we can do. The second question, first part, find the third term in the extension of this one. Let us see that one question. Now question number 2. Question number 2 first. We have to write the third term. P3. We have to write P3. P3 is equal to question mark. And given extension for given extension is 3x squared minus 2 by x raised to the power 8. Okay, and we want to write this third term P3. So P3 can be written as T2 plus 1. Okay, T2 plus 1. And remember this concept, TR plus 1 is equal to NCR, A raised to the power n minus r, B raised to the power r. This is a general term. Okay. So here we want the third term. Third term can be written T2 plus 1. So here it will be here minus sign, then minus 1 raised to the power. At the place of r, what will be 2, then 8C2, A raised to the power n minus r. At the place of a, here what is 3x square raised 8 minus 2 into 2 by x raised to the power 2. Like this one we can find. Okay. So here it will be now minus 1 raised to the power 2 positive. It will be positive 8C2 3x square raised to the power 8 minus 2 will be 6 and into 2 square it will be 4 and here x square. Okay, after calculation, whatever value we will get, that will be the third term in the extension of this. Okay. Similarly, other question you should try to solve and ask if you have the doubt. Okay. And I try to give its PDF form also. In the next video, we will see the sequence and series. Okay, sequence and series.